Okay, so um, I'm going to take us on Laplace transforms, the basics of Laplace transforms, and I believe this is going to be a fun tutorial, because a lack of understanding of the basics can make things awful. All right, quickly, let's go quickly into it. Now, when it comes to Laplace transform, this is what we have as the general formula. We have this as the general formula. So let me just say this quickly. You want to know the general rule for Laplace transform, the base rule that you use for solving, and this is the formula. The formula is the Laplace transform of a function f sorry Laplace transform of a function f sub t is equal to the integral from 0 to infinity. Then we have e raised power minus st f sub t dt. So when you know this general formula, it makes it easier for you to solve the Laplace transform of a function. Now take note, the function here is f sub t. F sub t is the function. F sub t is the function. And in the example we have f sub t, the function is given as f sub t equal to e raised power at. So this is actually f sub t that we are actually going to find the Laplace transform of. Now you have to remember that this formula is very essential if you are going to find it, especially this one here. Alright, so let's go back. We will need to write this formula down. So we have f sub t is equal to e raised power at, which is the first question you usually find in the textbook. Now using the formula, we have the Laplace transform of f sub t is equal to the integral from 0 to infinity of e raised power minus st dot the function now, e raised power at, the function. So then dt. So we now have the integral of 0 to infinity of e raised power minus st dot e raised power at dt, which will give us the integral of 0 to infinity. Now, according to the law of according to indices, when we have this and we have this, and there is a multiplication between them, then you can simply take a base. Then we have minus st plus at dt. Now, so that's going to give us the integral of 0 to infinity e raised power. Now we have a common factor here, so what we're going to do, we're going to pick out one t, then in brackets we have minus s plus a, then dt. Then we have equal to the integral from 0 to infinity of e raised power. Now when we have minus s and plus a, we take the a, let the a come forward, so we have t open brackets a minus s dt. Now by simply rearranging this, we have equal to the integral from 0 to infinity e raised power a minus s t dt. So we just brought the t here, there. So the next thing now we have to do is we have to understand some the use of some standard integrals and some standard differentials, which I'm going to show you very soon. That is going to help us with the next solution here. So quickly, let me show you some standard integrals that are necessary for this summation. The integral of e raised to power ax is 1 over a e raised to power ax. So in some other textbooks they might have different notations, but you need to understand that the integral of this function is actually dividing that function by the coefficient of the power. So we are dividing it by a. So that's why we have 1 over a. We simply divide by the coefficient this. So the integral of this function is actually dividing by the coefficient of the power, that's x. So you need to take note of that because we're going to need it in the solving. Now let's go back. The integral of this function is dividing by this function that we have here. So what we have is equal to, now we are finding the integral. So we are dividing by that a minus s. So we have 1 over a minus s just by the coefficient only, not t. Then we now have in brackets e raised to power. We will still write that the same thing back because according to the law of integration, we only have to divide by the coefficient. So we still have this e raised to power. Sorry, we only have e raised to power as. Then we have from 0 to infinity. So basically we have changed this to this. Now let's proceed. Now since we have the lower limit of 0 and the upper limit of infinity, we are writing this out again as 1 over a minus s. Now we have the upper limit to be infinity, so we have e raised to power a minus s infinity. Then we have the lower limit of 0, so we have minus e raised to power a minus s, then 0. Yes, if you've done some basic integration, you understand that. Okay, now so let's proceed. Therefore we have equal to 1 over a minus s, open brackets, e raised to power a minus s infinity minus e raised to power a minus s 0. So from there we are going to have, now you have to take note of this. E raised to power 0 is 1 and e raised to power infinity is 0. So you have to take note of these two things, very essential. So if you look at this place, infinity here, when you multiply a minus s, everything will give you infinity because infinity is endless. Whatever you multiply by infinity still gives you infinity. So we end up with 1 over a minus s, open your brackets, e raised to power infinity minus e raised to power 0. So I believe you get that. So according to the previous rule, I told us that e raised to power 0 is 1 and e raised to power infinity is 0. So coming here, we'll have 1 over a minus s in bracket e raised to power infinity is 0. So we have 0 minus 1. So lastly, we are going to have this equal to 1 over a minus s minus 1. 0 minus 1 is minus 1. That will give us minus 1 over a minus s. And that will give us, now since we have minus up, we bring the minus down. So basically what we have is 1 over, bringing the minus down, minus a minus s. And that gives us 1 over, now the minus of, this minus attacks this a and attacks this s. Now remember that this s has a minus. So the minus here, we turn this minus to plus. So we are going to have minus times a is minus a, then minus times minus s is plus s. Definitely we are going to have as our final answer 1 over s rearranging minus a. So the Laplace transform of e raised to power at is 1 over s minus a. So this is our final answer.